Hello everyone, this is the video lecture for Math 1314, section 2.5, Transformations of Functions. Okay, so this this section of the workbook is probably the worst that I'm sorry. I know that the people who put this together, they did such a great job. They honestly did. It's such a great workbook. But this section just irks me, and it's just because it's not my own style. It's not my own style, man. So I'm gonna follow the workbook. I will do it. But I have awesome lecture videos on YouTube about this very same topic, and I break out and do a super awesome lecture on it. I totally recommend. I don't have a link in the description below, but you can find it. Search my channel and go to Math 1314 and look for section 2.5, and it'll be fine. You will love it. Transformations. It's awesome. But here, today, right now, I'm going to follow the workbook instead. So, this one's a little bit bigger, so I have to, not care for a second about this stuff. But we got all these different parent functions. And so we got absolute value, looks like a V. We got quadratic, looks like a this. And square root looks like a that. And all these cool things, right? I call this the whoosh. This is the whoosh. I don't know if I spelled it right. Maybe there's another H in there. Anyways, the whoosh. And we're going to do all kind of fun things with these as we go. But also, my math lab provides whole other new ones that kind of throw you off anyways. So can I just use Desmos to graph all this, right? I mean, come on, man. Yeah, no. No. You go to the homework, you're going to be totally disappointed. So you got to do it by hand, and that's fine. It's fun. It's fun. We've talked about this. It's fun, right? Like function fun. It's fun. Vertical translation, what are they talking about? They're talking about up and down. Okay? Let me show you how this works. And so there's essentially this plus and minus on the outside. On the outside, you have this plus and minus. For example, let's say I have x squared plus 3. So my original x squared looks like this. But then I'm going to go up 3. Up 3. 1, 2, 3. Draw the same thing. Ta-da, we're done. What about the other way? What if I had x squared minus 4? So minus means down. So my original looks like this. And 1, 2, 3, 4, kaboom, kaboom. All right, for an example, let me just show you. So let's say I had x squared, and then I had x squared plus 3. You can see that the red original, and then the green above it. And there you go. Or you can say x squared minus 4. And so now you can turn that one off because now it's annoying. The original red, and now you got your purple below it. That's fine, but your homework will not be so Desmos graphing-y. It'll be more like this. So they're going to give you a picture. This is simply just a picture, okay? And I call this the ziggy-zag. The ziggy-zag picture. And I want my ziggy-zag to do stuff. So my ziggy-zag is what? It's going up by 2. Pick which one. Right? Because it went up by 2. You can zoom in. Let me zoom in. Hold on, let me click on it. Nah, it ain't working. Anyways. The ziggy-zag goes up 2. All right. Well, that was it. Oh, man. There's a lot more of these on your homework. Okay, that's fine. Let's keep going. So I got to remember that I have a separate lecture video just for this section specifically. I just break out into it. It's awesome lecture video. Go look for it, okay? Anyways, horizontal translation. So we're shifting again, but we're going side to side. So I'm going to say side to side. And this is now on the inside, but I also have to stress inside opposites. I didn't spell it right. Inside opposites. Inside opposites. Inside. Did you say it? I didn't hear you. Anyways, opposites. So this is when you have something on the inside. They use a H. Okay, fine. And I'm going to put a minus plus in here. We don't normally see minus plus. We see plus and minus. Why did I put a minus plus? Because it's opposites. Let me give you some examples. So let's do x minus 3 squared. So my original is the square. It looks like that. But now I have this thing on the inside. Inside, opposites. We're actually going to the right. Yeah, the minus you would think, oh, I'm going to go to the left over. Nuh-uh. You're going to the right. Opposites. This is positive land, man. 1, 2, 3. Boom. And we're good. Let's do it again. Let's say that I had x plus 4 and then squaring it. Oh, yeah. Plus 4. We're going to go to the plus. No, you ain't going to the plus. Nope. That's a minus. Opposites. We're going to the left side. So here's my original. 1, 2, 3, 4. And we're good. There it is. Yeah, I can verify it, all right? We can verify this stuff. Here's your original x squared. I'm going to go x plus 4 squared. Where did it go? To the left. Minus went to the right. There it is. Proven. I just get to Control Z. I want to just delete it, though. All right, we're good. Okay. Why is it opposites, though? And that's kind of weird, isn't it? Just hold on for a second. Here's an interesting thought. This guy. This guy. This guy. Solve for x. Solve for x. Have you seen that guy before? Solve for x. Come on. Solve for x. Oh, yeah, he's 3. He's 3. He's a positive 3. 1, 2, positive 3. Boom. There it is. This guy right here. Same thing. Solve for x. Come on. I know you can do it. Oh, did you say negative 4? Did you mean negative 4? Look at that. Sorry. I get into it a little bit. My bad. All right, keep going. So right here, plus 6. Positive 6. We're going to the left. That guy. And again, you can do this one. Okay? That's easy. But they're not going to be like that in your homework. They're going to be like that. I call this one Hilltop. So Hilltop, right here, outside, regular. We're going up. Inside, opposites. That's going to the left. So we're going to the left, and we're also going up. Pick which one. Exactly. Hard break. New topic here. So they say there's a negative in the front. It makes it reflect. So perfect example. Let's say I had negative x squared. Notice that there's a negative in the front. So my original looks like that. The new one is upside down. It's a vertical reflection because it's like a reflection is like, in the water or in the mirror, but it's up and down. So yeah, negative in the front makes it flip. Oh yeah, that's what I like to call it. Flip. Ziggy-zag. And look, there's a minus sign in the front. So I'm going to flip it. So this zag is up here and this zig goes down there. As in, like, it should kind of look like that. No, wait. That was the original. No. Right there. I am totally dyslexic, by the way. And I mean, I know you're thinking, you're doing a lot of math. How can you be dyslexic? Well, I mean, it happens, okay? So these graphs, like, really throw me off sometimes. And I want to pause for a second again. Oh, man. This is on your exam. This question, you're looking at it right now. That's on your exam. And you know how easy it is? Look. Oh, I've seen this before. Burp, burp. And you keep moving, right? You know how easy it is? Come on. Oh, I've seen this before. Burp, burp. And we keep moving. You just got it wrong. And there's nothing I can do. There's nothing you can do. You got it wrong. I don't want that. I don't want you to get it wrong just for speed's sake. Take an extra second. Undyslexic yourself. And I mean, it's hard. I do the same thing. I have to think about it. Keep moving. Okay. So this is where, like, again, it's not in the order that I want to do it, but it's fine. I'm just doing the workbook. It's going to be okay. So vertical shrink versus all this other stuff, what they're talking about is, like, say I have a 1/3 in the front versus what if I have a 3 in the front? So this number in the front is either going to shrink it or stretch it. That's what they're kind of saying here. So this is going to shrink it. This is a 1/3 as tall. Fall? Still fall. Tall. 1/3 is tall. And this is triple the height. So here we go. My original looks like this. But then I need a third as tall. I need it like a third as high. Like I'm squishing it. Shrinking, squishing. It goes like this. It's kind of like this, all right? And then my original here, and I'm wanting it triple the height. So wherever it was, I'm going to go triple the height. Wham! I'm going to stretch it out. Wham! Stretching it out. Let's do this in decimal. So like we got my x squared. This is my original, and then I got a 3x squared. See, the blue one is more stretched out. It's like a rubber band. I'm stretching it out this way. Sound effects included. Okay, so looking at this guy right here, an easy thing right here. Up, hold up. That's a left. Very good. And then the 2 is saying that we're gonna double the height. Now, they all double the height, by the way. I mean, doubling the height looks kind of like this. So we doubled the height for all of them. But which one went up and to the left? Which one went up and to the left? Okay. And do it again. So it says, which one is this? This is to the left. Again, that 2 means double the height. So, left, double the height? I think so. I mean, you can just verify. Let's just verify. We've got some decimals, right? There you go. Okay, another one. I got a half in the front, so this is going to be half as tall. And this one went to the right. So it went to the right, and now it's half as tall. It's kind of like this. It's like a flatter mountain. I'm like squishing it from both sides, actually. So it ain't one of these guys. It was definitely one of those. And you can barely see the difference. But which one actually went to the right a little bit more is this guy right here. So there we go. All right, horizontal reflection. Now, this is where I need to start changing my function up, and I'm going to start using the whoosh. Yeah, exactly. So I'm going to compare a regular square root versus a negative square root. So the regular square root looks like this. This is just a plain old square root x. This over here is a square root of negative x. And notice that it's on the inside. And that's like reflecting it horizontally. Or you could say like my x values are now negative. See, negative x values. You might be thinking, if you're really on it, oh, how can you have a square root with negatives inside? You can't do square root of negatives. Yeah, I know. But like if you had a negative 4, 2 negatives make a positive. Oh, no. We're going to do this face. Little devious. Anyways, moving on. This guy right here, we have down. And we're going to reflect it like side to side flip. So it's like a flip, but side to side. Oh, yeah, by the way, what does that look? See how it's a flip side to side? Yeah, okay. Yeah, just wanted to remind you. So yeah, this guy's going to flip side to side, and he's going down. Down. One of these guys are down. This one flipped. Okay, oh man, topics. Okay, anyways, what did I put in my workbook for this one? Because I might have just skipped over it. I don't know. I don't like the order of this stuff. I'm sorry. Yeah, I did that part. I actually did do something here. Okay. That's fine. So, I got y is equal to the square root of half x versus y is equal to the square root of 2x. Let me just draw them. So there's my original, and no, this is my original, and that's the new one. This is the new one. I'm going to write new. And then for this one here, I got this, and there's my original. So this is the new one. Okay, I don't know. I'm just stretching it horizontally versus here I'm compressing it horizontally. I mean, it's kind of like here I'm going with a rubber band or with a rubber band. Anyways, it's just the inside opposites. Inside, come on, inside, opposites. Half. How is that stretching it out? How is it being more stretched out there? Because it's opposites. 2. How is that shrinking it? Shouldn't it be double the x? It's half the x. Anyways, so yeah, this is the one question where it like ever will show up, I'm sure. 2 is on the inside. Again, we're thinking opposites. So it's actually half. and we're going to be compressing this thing. Now, automatically I went, woohoo! Oh, wait, sorry, I went too far. Yeah, it's actually this one because, yes, it's going inward, but the height isn't changing. The height is not changing. Watch out for that. Oh, we're done. That was it. There's one other one on the homework that is so cool, but again, I would go to my other lecture video for this section in particular. I really did an awesome job on it, I think, and just go check it out. That's all I got here. Thank you very much. Have a great day.